Hi everyone, good morning. So today I want to introduce you a 1000 liter brew house which is working in our office building here. And most of the time we are using this brew house for the training and recipe researching. So let's get inside and we have start. Here is where our brewery is, and this side is our brew house, and this side is the fermenters. Luckily, today is also our brewing day, and we are doing 2 brews wheat beer for today. So as you can imagine, it can be a better opportunity to help you understand how our system working. So if you are also planning for your own brewery, and I hope our brewing process can also bring you some ideas that helps you with another perfect brewery for yourself. So now we need to start brewing and the malt is ready. Let's go. As you know, we are making the brewery in our office building, and we never have the enough space to make everything fit inside. And here is very basic malt transport system. We use the double roller malt mill. This is from Germany, and this is very basic chain disc conveyor, which is connected with the grease hydrator above mash tun. So with this system here, we are feeding malt manually from the small hopper here, and after the milling, we have the milled malt going inside the conveyor to the grease hydrator above the mash tun. So right now, I am standing on the platform of our brew house, and it's a 4-vessel brew house with the basic configuration of mash tun, lauter, kettle, and whirlpool. It's a fully automatic system. Here is the grease hydrator. We just finished the mashing, and right now we are waiting for the step mashing. Next stage, we will transfer the mash liquid to the lauter tun here. So this is our lauter tun. Like the mash tun, we have the lauter tun also installed with the bottom stirrer. You know why? Because with the bottom stirrer, we have very short connection at the bottom part, and this helps with lowering the twist force, and it's good for extending the using life of the tank, especially the stirrer unit. This is our water sink. So we have this water sink connected with both lauter tun and the kettle. And here we have 2 sample wells, and we use these 2 sample wells for taking the sample from lautering process and boiling process. And here is a very tiny cylinder, and we use this stuff for testing the Plato. start the boiling. And here is our kettle. With this tank, we have a steam jacket on side and bottom, and both jackets can be controlled separately in case you want to do some small batch brewing or some other special beers. And also, inside this tank, we have the internal heater, which helps with increasing the evaporation a lot. And this is our hops dozer. Normally, when you are doing the brewing process under the automation, it's dangerous to open the one way. So you just open this small one way and keep the hops inside. Then after that, you just leave that to the computer. There's one small thing with the kettle, and here is a foam sensor. Why we have this? This is the stuff connected with the pressure sensor installed on the steam line, and also is together with the PLC system. Why we are doing this? Because with this sensor here, we can bring more stable and better regulation for the steam supply. Then finally, the whole boiling process can be with even better evaporation. So after the boiling process, and we have the whirlpool, and this is our whirlpool tank. This tank is designed with a flat bottom, and for more details, it's better that we go downstairs and I show you. So right now I am underneath the mash tun. Like I explained just now, we have the bottom server for the mash tun and steam for lauter tun. Since we are doing mostly the automatic brewing process, and we have something special for the mash tun and of course for other tanks. And for the mash tun, we have the pressure sensor installed at the bottom part of the tank. And here we also have another empty flow sensor, which is also connected with the PLC for the automatic brewing. So for the next step, we need to transfer the mash liquid from mash tun to a lauter tun. What's special for the pump? Because we need to make sure that we have the mash liquid transfer going to the lauter tun very gently. So the pump needs to be with big flow but lower pressure height. And we have the mash inlet just above the filter plate. So this is also the process that we can do better mash liquid transfer. And here is the valve for the spinning going out. It's a pneumatic valve and connected with the PLC system. So normally after every time you finishing the lautering process, you just put the spinning grain cap in here and just wait the automatic grain spinning out. Here is a small unit, and we call it buffer column. Why we are having this? Because this is the stuff connected with the lauter tun. So every time when you are doing the lautering process, you have the words firstly going to this column, and after that going to the kettle. Because with this, we make sure that we always having the wort pumping out, not the air. Because if there is the risk that you have the vacuum status and the filter plate, this is really bad. And for the pump here, the lauter, I think by making a good brewery and you want the better lautering process, you need to make sure that the pump is with not really big flow rate and pressure height. And this is also a way that helps you with a better grain bed inside the lateral tank. So with a coil pipe inside our steam condenser, and we do the water circulation during the boiling process. So this is a way that we can make full use of the steam. So for the big breweries or some people, they want to save the energy cost. This is the way. And here we have the inlet for the water in, and at the upper part we have the regulation valve there installed with the outlet. So during the boiling process, we have the water circulation, and after every circulation, we have the hot water out at the temperature like 80 to 85 degrees, and we have the water, hot water, going back to the hot water tank for the new brews. So with our kettle here, like I said, we have the steam jacket on side part, bottom part, and also the internal heater inside the tank. So for every boiling process, we can bring the evaporation rate like 8 to 10%. So this is a good way to make sure that you have perfect DMS. And here is our whirlpool tank. And whirlpool is whirlpool, there's nothing special. But what's special here? We have 3 outlets for the clear water out. And for every outlet, we have the empty flow sensor connected with the PLC system. This is the way that we make sure we can get the maximum watt output from the whirlpool process of each brew. There's one thing for most of the breweries, there's always a big challenge for the heat exchanger part, because the cleaning of the heat exchanger is always complicated, and it's a big challenge because once you cannot make the perfect cleaning, and you probably have the problem with the beer quality. And we have a filtration unit before the wort going to the heat exchanger. So like here, we have 2 strainers here, and every time we have the wort transferring from the whirlpool to the heat exchanger, we have the wort firstly going to the strainer here, while we are having 2. So you have the hops and other ingredients in the wort, and there are sometimes you have the strainer being sucked inside. So once this happens, we can just switch to the other one automatically. Then by this way, we create the pre-filtration before the wort cooling, and also we don't stop brewing. So this area is our cellar part, and we have 6 fermenters of 1000 each. All 6 fermenters connected, and for the back side we have the stainless steel piping fixed. And actually for all the new projects, we can do all the glycol piping pre-assembled in our workshop. So when there is the request for on-site installation, you just put the tanks on the right position and make the quick connection. So this is a way that we can save a lot of labor and time. So for each fermenter, we have the basic configuration like this. And for this tank, we do the side mount way. But of course, we have the option for the top mount way. And here is the connection for the carbonation. And here is for sampling. And this is pigtail. Now when we are making the sample, we don't need the foam. So this is the device for removing the foam while taking the sample. And here is our CRP arm, and this is a bunkering device, pressure gauge. And what's more important here, we have one more valve here, because when there's sometimes we need to fix this bunkering device, we can still make sure that we have the right pressure inside the tank, so we never ruin the beer. And for the bottom part, we have 2 outlets. Actually, this is they are separately for beer and yeast. and the one for beer is inside with some higher position. So the back side of me is the glycol tank, and this is connected with all the fermenters. We use this tank and connected with the pump for the glycol supply during the fermentation process for cooling the beer. And what's more important here, and I can only say this is kind of a better guarantee for the glycol supply. And we use 2 pumps together here, and here we have 2 pumps connected together. You know, with by using 1 pump, there is sometimes the potential risk that once you have problem with the pump, you have the risk that you have to stop the glycol supply in the system. But this is really bad when you stop that, because when the temperature changes inside the tank, and you have the beer quality also change. So that's why we are having 2 pumps here. So just in case we need to maintain one of the pump, we can just switch to another one, and we make sure that the system is always supplying the glycol to the tanks for maintaining the temperature inside the tank. So now we are moving to the control system here, and in front of me we have 2 control cabinets, and there's one more at the back side of me. So as you can imagine, the configuration of our control system is more complicated compared with the manual system, because we need more function and more electric stuff inside the panel for supporting the whole automatic brewing request. And here is a computer. We use this computer for operating the whole system. And the software we're using is BrewMax from ProLate in Germany. And this is a part for the whole automatic brewing operation. So for now, this is almost the end of the brewing day, and I wish that you are also the people like us, that you always enjoy every brewing journey. So if you are interested in our brewing system here, you are always more than welcome to be here for sharing knowledge, and we brew together. And if you are also planning your own brewery, you are just feel free to contact with us in case we can help you with any possible recommendation or some proposals. And finally, we want to say, if you want to make it higher quality beer, you do need a really good brewery. So the quality always matters. So if you are also planning for your own state-of-the-art brewery, you just feel free to contact with us in case we can help you with some recommendation of the possible proposal. And finally, I want to say, if you want to brew the higher quality beer, you do need a really good brewery. Good breweries always means the quality. So for us, the quality always matters. It's a good day, and we are looking forward to sharing with you together again by next brewing day.